Greetings, everyone. It's Wednesday, December 4th, 2019, and this is RealTuners Radio, episode 107. Tonight, we have one of your favorite guests returning to take some listener questions. His last visit was August 1st, 2018, and his episode on lubricant testing is one of our most popular. Tonight, we welcome back Lake Speed Jr. to the show, and he also has some big news to share with us. As always, thanks to our hosts who help keep this car going straight down the track. John Bewley, Little John Motorsport Solutions, Bill Fowler from Big Hat Racing, Scott Evans with Helix Tuning, James Short from Shore Tuning, Mike Perduto from Synergy Tuning Systems, Mark Dahlquist from Throttles Performance, and Brian Barnhill from TunerTools.com. Now let's get to the staging lanes and warm this engine up. Welcome to RealTuners Radio. All right, welcome back. How's it going, everybody? So, what is it? December 4th, 2019. Cruising right through the holidays. Got a lot of stuff to talk about tonight. The $110 pie for Thanksgiving was actually 3 pies, but it's a funny story. We kind of want to talk a little bit about these guys that did this Cannonball Run thing, this kind of amazing record, or an unofficial Cannonball. And then we got one of our most favorite, just love having this guy on the show, one of our most popular guests too, one of our most downloaded shows. Lake Speed Jr. is back with us, and he's got a big announcement, kind of some new stuff he's working on in his career, and just excited to have him. We were having a great chat here before the show with this guy, just one of the best to have on here. Love this guy. So all y'all, welcome back to the show. Let's just go ahead and get things started. I'll go ahead and bring my guys in here then. Let's see. Okay. Just checking to see if my guest can hear us. Mr. Speed Jr., are you there?
I am here.
Yes, outstanding. Okay, cool. Everybody else can hear us. Well, welcome back, man. It's good to have you. Just kind of laid back tonight. No special presentation prepared. That's what we asked for. We just kind of wanted to take some questions because we always have people asking questions. But why don't you give us an update on what's going on? Just go ahead and give us a little background and what's going on lately in your world.
Okay, I appreciate it. I'm very thankful for everybody that requested me to come back. I still remember doing the first episode from my office back in my basement at home, and it was great. And here I am now at Matt Hartford's house in Phoenix, Arizona. And the reason I'm at Matt's house is, because people might know that Matt Hartford is now the CEO of Total Seal Piston Rings. And as of Monday, I am now a 100% Team Total Seal member. So I've left Driven.
Huge congratulations.
And joined Total Seal. Well, thank you. I appreciate it. Like we were talking about, beforehand. I've been with Driven for 15 years. I started there when it was Joe Gibbs Racing, working for Mark Cronquist, who's the head engine guy at Joe Gibbs Racing, who's my mentor. And I'm the reason I'm even here talking to you guys, and even when he will even listen to me, is because Mark Cronquist, for some unknown reason, 15 years ago said, "All right, we hired you to kind of take over the oil program and be our liaison with Lubrizol and all this. You're my oil guy. You get to know everything about any part in these engines that's touched by oil." Just let that sink in for a minute, guys. That meant at 30 years old, I got to know everything about a Cup engine. In 2004, NASCAR Cup engines, we had a development deal with McLaren. Formula One. That's when McLaren was good in Formula One, by the way. You get to know everything about these engines that touches oil. If oil doesn't touch it, then you don't get to know about it. But
let's just be honest. Cup car engine development is the top of the game in domestic V8 development in this country and damn near the world.
Oh, it is.
Yeah.
Well, it is. The Formula One stuff is on a different planet than us. It just is. It's crazy. I got to go over there in January. And the funny thing is, I got to go over in January with the group from North Carolina, and we went to McLaren, we went to Renault, went to Ilmor. Oh my God, I mean, this is RealTuners, right? So we're engine people.
Yeah.
There's two places in the world that are like the mecca for all of us. Let's just be real. It's Cosworth and it's Ilmor. And to go see Mario Illen's creation, the pushrod V8, that won Indianapolis, it's the freaking greatest engine ever. It got banned after one race. It's to see it, to touch it. Are you kidding me? It was incredible. It was great. It's a fantastic experience. Well, anyway, long story short, you go over there and to see the battalion, not a troop, a battalion of engineers and the amount of data they processed. So just to kind of give everybody a perspective, we were sitting there talking with Rob White, who was formerly the head of engine development for Renault. And that's back when Renault was winning championships with Red Bull as their engine supplier. He told me that last year, Renault processed over 1 billion simulations.
God.
1 billion. Do the math. That's several million simulations a day.
Right.
I mean, that's
so they
CSD
have
simulations, that's pit strategy simulations, that's engine. I mean, what?
Supercomputing. Those guys are using supercomputing size servers to run through all these different models and simulations. Yeah, it's nuts. Absolutely. Everything from aerodynamics to in engine internal stuff that's just ridiculous. Intake manifolds. Yeah, I know a little bit about what goes on there. That's obscene. Getting to see that in person. You are the man.
It is.
Well, what's the saying?
Wait.
Sorry, I was going to say the saying is that NASA gets the leftover engineers from F1. So
right.
Well, to validate that comment, when we were at McLaren, they were telling us that one of their sponsors is Boeing, because Boeing comes to them for help.
Yeah. Wow.
Yep, I've heard that a lot.
Yeah.
God.
Yeah. The best engineers are in Formula One. The best.
I'm
like, okay, we are hillbillies.
Yeah, we are hillbillies. Correct. Ugh, that's too cool.
So anyway, long story short, it's we got way off on a tangent, but hey, that's probably going to happen tonight. But that's good. Right?
That's
fine.
Great.
Hopefully.
Yeah.
But anyway, so Mark was really great with me several years ago to allow me to have that insight and opportunity to really learn a lot about a NASCAR engine. And then, that led to my relationship with Matt Hartford and Keith Jones and Kevin Studeaker and Bobby Cheeseman and Rick Lenniger and all the guys at Total Seal. They've been a customer of ours at Driven for 8 years. In fact, the current formulation of oil we have or Driven has today, I'm still working on my pronouns, right? It's only been 3 days. Was developed in response to, hey, Keith and Matt and those guys, hey, can you get ring seal better? Yeah, I know this oil works really, really good for flat tap valve train. But when we get into these, real small, 0.8, 0.7, 0.5 millimeter rings that are tool steel, that are coated, that's climbing the top of the mountain. And there's big horsepower there. And we'll talk about that later. And I've got some stuff I want to talk about that. That I've experienced firsthand in the engines that we were doing. So just to give you an idea, a couple of years ago when they were talking about this, they said, we need help with break-in oil on this. So I said, okay, here, tell you what, I said, Keith, for a wet sump engine pulling no vacuum, give me what you think is the craziest on-edge ring package. Now, this is going back 6 years ago. They said, all right, we got a 0.9 millimeter, 2 mil oil ring package, tool steel, diamond finished rings. Give that a go. All right. So we said, all right, put that thing in there. We had 043 rings in there before, good stuff. And we put it in, ran that thing on some braking oil. And we tried 4 different versions of braking oil to try to get the rings to seat. And one of them, that thing sealed up really nice. It was really good. And it would stay sealed up with that formula. 30 minutes, make about 6 hits. It was nice and steady. That was 10.5 average better than the 043 ring. Just changing from an 043 to a 0.9. This is on a 450 horsepower motor. This is 10.5 the whole way.
That's huge.
Average.
Yeah, that's huge. Across the board? Yeah, that's huge.
Across the board. Well, then, I said, okay, wow, we did something. All right, keep on going. Then we're continuing to work on formulations, trying to push things. And they came back to us, and they said, all right, we want to try something again. We got some new stuff we want to try. I said, all right, we're going to send you a 0.7 millimeter 2 mil oil control ring. All right, now we're really getting ballsy, right? To put this thing on, I will never forget. We do a lot of testing out there at Ron Shaver's place, and he's probably not listening, but I mean, if he's out there, Don McCaskill and Keith Crisco and Dan Brewer are the guys there at Shaver's that they build the engines, run the dyno, and those guys have been great with me and taught me so much. They built all the Donnie Schatz motors that have won all those championships, and we go and do the first one to break in, do the 30-minute cam break in. And then, because we're working with Billy Godbolt, we kind of try to double dip where we can, do a flat tap the cam break in, try a ring, same time, flop out the cams, the next one, and keep going. Because it takes a little bit for the rings to really fully come in, right? So we put in the first oil, we run it, 30 minutes, make 2 hits, and looks good, man. Pull the headers off, ports are nice and dry. We're like, wow. And there's spark plugs totally dry, ports bone dry. We're like, man, that's awesome, right? Feeling pretty good. Pop it out. Well, we had somebody say, hey, we want you to try this additive package for break-in that we think should be really, really good for flat tapping cams. Okay. Put that one in next. Again, we're doing a 30-minute run-in, 2,800 RPM, 15% load, on the dyno. So that's pulling, with that engine, that's pulling about 75 foot-pounds at 2,800 RPM. We're running. They got the clock running. About 15 minutes into it. Yeah. The engine's missing. So we're looking at everything and checking it all out. We walk in there and start listening. Just check all the spark plugs, make sure, do we do something wrong when we swap the cam? And you're like, check the timing. It's like, thing's missing. All right, we'll get to the end and make a couple hits, make 2 hits, and the thing is, it's all over the place. It's unhappy. You can hear it in the shop, and Ron Shaver's even walking back. What the hell y'all doing back here? And we're like, Ron, that's whatever. Because Big Daddy Ron, he's great for us. And we go ahead and pull the cam out because we're thinking, okay, well, we killed the cam, right? We pulled the cam out. Cam's fine. It looks really good, actually. Like, damn, we'll pull the spark plugs out. About half of them are oily. Pull the headers off. Half the damn ports got oil in them, like a streak of oil in them. We're like, oh crap. Of course, Ron comes back. Oh, y'all are done now. You got that damn small ring. I told you couldn't run that thing. Type deal. He said, it's oiling now. We're gonna have to pull it back and rehone it. Because it's done. We're done. I said, well, hang on. It was just sealed up on the first oil. We got 2 more cams we need to break in. Why don't we do this? Why don't we swap it back? Put the first oil back in. We got enough. We'll put a new cam in, do another one. Said, hey, it's your motor, do what you want to do. So, all right, we do that. We swap it back, put in the first oil again, new cam, run it in. It seals back up completely. Power numbers are the same. The mist goes away, and they all fell on the floor. So we've never seen an engine start oiling like that and then recover, ever. And, that's the kind of stuff that and again, this experience of working with Keith and Matt and all the guys at Total Seal, we were a team, in developing this stuff, and we learned a whole lot about piston ring seal. And, I can't remember how much we talked about last time, but the last 3 years, at Driven, we did a lot of work with General Motors and Oak Ridge National Lab on some, really advanced technology, stuff that's not even on the market yet. I mean, it's basically all R&D. Literally, a lab scientist at Oak Ridge National Lab would make 10 grams of the additive at a time. I mean, that's how small they were making molecules, making this ionic liquid stuff. And we would take it, and we would go put it together. We would go, blend oils from it and go do this testing. And in the testing, GM is just finishing up the test. This month was the end of the project. The project ended. We were able to make a 0W12. That's right, 0W12 oil that we ran in an LT1 direct injection engine. And we ran that oil at 340 degrees Fahrenheit oil temperature. Baseline that against GM's 5W30 Dexos Gen 2 oil spec, their factory fill spec. We got 9% fuel economy advantage and reduced wear with this stuff.
Really?
It was ridiculous.
Yeah,
9%.
that's huge.
That's
9%.
They'd pay millions
is,
for that.
Yeah, my guess is they're testing in the drive cycle range, right? Which is the same place they work the emissions testing. So, yeah, I could see that.
Well,
that's
so
amazing.
the drive cycle test, right? Well, we did that in a really that was kind of our race simulation test, where we were cycling up and down the RPM range. We're way more aggressive in our test. When they ran their test, it was like a 2% fuel economy gain. Still huge, right? But not as crazy as ours, because our test was a little more aggressive. But the wear test still came back the same thing, is that we went from a 530 to a 012 and reduced wear. Didn't increase it, we reduced it. In fact, even the test we did some tests we did recently was driven with that same additive in a stamped steel rocker arm engine. Flat tap it. It had a quarter of the wear as Shell Rotella T. Quarter. Wow. Right? And there's a lot of people that think Shell Rotella T is it's a good oil because it's cheap and you can get zinc. And you know what? Rotella T typically won't blow up your engine unless it's a direct injection engine. That's a totally different subject, But
right.
Because the calcium level is just wrong.
I can already see myself at the front counter. Guy comes in with his new pickup. We're doing a 7-quart oil change, and we're using the GM recommended 0W12 oil for 9% fuel economy gain, and your oil change will be $397, please.
Yeah, you're about right, dude. That's not far off.
Yeah,
the stuff is crazy expensive right now.
That's
the
what I
is,
figured.
We have done a lot of work and saw some great stuff, and that's kind of what led me to the point where we were talking about before the show started. I thought I climbed the top of the mountain.
I was just going to say, do you ever feel like you've kind of reached a pinnacle? Did you say, all right, I've done the highest end of stuff. Where else is there to go but somewhere else? I mean, I don't know. Maybe you feel that way.
That
maybe
was kind of, this toward the end, when we were starting to get the results back from GM's testing in the last few months, I felt that way. It's like, what's next? I mean, what do I do next? I don't know what is where else to go. And then, with Matt becoming the CEO now at Total Seal, and they're really trying to advance the stuff. And Total Seal, again, this is a great company. The Total Seal supplies the top teams in the world, right? We have a very strict confidentiality agreements. We cannot disclose who our customers are, but just imagine the highest level of motorsports anywhere in the world. We supply them with custom designed piston rings.
So just going through Total Seal,
we're really good at it.
Just going through their slideshow, their photos on Facebook would give you an idea of the level of motorsports. These guys are everywhere from go-karts to really, really high-end road race cars, cup car stuff. Hell, I saw you guys, there was stuff from at Keith Dorton at Automotive Specialists. Those guys, you guys are pretty much everywhere. So man, that's really going to be a position for you to kind of spread your wings and grow. That's going to be awesome. Too bad you're not going to be able to talk about your greatest adventures there.
Well, no, it's like, this way, we're going to Europe next month, to go see people and do some things, already, and that's the thing is that, it's, like I said the other day when I made the announcement, that to me, the piston ring is your oil's best friend, right? I mean, for all of us engine guys, we have to realize, what kills the oil is contamination. I mean, that's really the thing that destroys it. You may not know it, but a quart of motor oil is two things: 85% base oil, 15% additives. So that's what motor oil is. The same base oil that's used to make, regular motor oil, like you get at Jiffy Lube or wherever else, is the same base oil that is being used to make transmission fluid, to make gear oils, to make industrial turbine engine oil. Well, think about it. Even your daily driver, even with the oil life monitors and all this, it might go 10,000 miles-ish before you change it. But there are ATFs that are filled for life. You never change it. Well, what's the difference? Contamination. And of course, ATFs don't run as hot as engine oils. Unless you're crazy drag racing and you got trans braking and all that. We get that. But that industrial turbine, it does run as hot as an engine. But that industrial turbine oil will last 20 years. Just let that sink in for a minute. The same base oil, it will last 20 years in an industrial turbine engine, last maybe 10,000 miles in an internal combustion engine.
Are they doing anything special filtration? Like, are they running like a centrifugal filtration or something like that? Okay. Wow.
No.
It's completely avoid contaminants.
It's exposed to heat. Yeah, it's that, hey, in a turbine, the combustion gases are never exposed to the oil.
Yeah.
Whereas in an internal combustion engine, it is. That's, if you go way back in Total Sales history, that's what Joe Moriarty Sr., made his name on, was the gapless ring. Of course, listen, Total Sales technology has come way beyond the gapless ring, right? We are not a gapless ring company. I mean, I can tell you right now, the majority of those top tier teams that we sell rings to do not run gapless rings. That's not what we're selling for the top end guys.
Right.
That is not our best technology. People think of us that way, but that's not our best technology. Our best technology are things outside of the gapless ring. Are gapless rings great? They are. It's just like motor oil. I say oil in general. We talked about it last time. The best gear oil in the whole world is still an awful engine oil. It's chemically not right for the application. Application dictates the chemistry, just like tires, right? The best tire for, a wet track is the worst tire, for road racing in the dry, because you're just not going to get grip, right? But that great slick tire that gives you grip in the dry is awful when the road is wet, and it's going to be really terrible on ice. So it's the application dictates the chemistry is what I've always lived. Well, it really is the same thing when it comes to piston rings. The application dictates the chemistry. The gapless ring has a place in some applications where you have excessive fuel dilution and you need every little bit of barrier to keep the stuff above the piston from getting into the crankcase and killing your oil. But there's other times when you've got better fuel control, right? Which we hope all aspire to do, right? Is have the right amount of fuel in the combustion chamber at the right time. Not too much, not too little. We want to be the three bears and get it just right. That when you have that opens up things you can do with the ring package. And when you go to a lower tension, lower or smaller size ring package, not only do you get better ring seal, which is going to translate to better efficiency, now you get longer oil life and your oil works better. Again, that's the real impetus for me coming here, is because I realized you know what? I can make the best oil in the world. I can make that 012, but if the tune-up is totally wrong, if the ring seal is terrible, it doesn't matter how good that oil is. You killed it with contamination.
You keep talking about contamination. What are the major players in contamination? I'm assuming combustion byproducts and probably the piston walls wearing down on the rings. Where else does it come from?
Yes. Well, so contamination, is going to come primarily from the blow-by gases, which there's going to be, hydrocarbons as well as moisture. I mean, think about it. Every combustion event does make water. It's in the form of a vapor at that point, but anything that gets past that ring is going to contain water. And if the engine gets cool, it can condense. So there's going to be water in the oil, and water is really bad. Water will basically deactivate the ZDDP. It deactivates the zinc. So that's an important thing to keep in mind, is trying to do that. Unburnt fuel, that's one thing, I think we talked about last time. My daughter is doing the speed diagnostics used oil analysis service. And so she's been doing that for about 2 years now. And of course, I'll help her out, kind of watching the background. And especially when she has a report that's bad, that give the person the right guidance. I can tell you for a fact that in 99 out of 100 samples that have a problem, fuel dilution is the reason for the problem.
No kidding.
Nothing else.
Yeah.
No kidding.
So fuel
dilution is the number one problem.
Can we combine some of the things that you've talked about a little bit for a lot of our listeners who are trying to get all of this? By the way, I did a little math in the background, and if you drive 12,000 miles a year and something that gets 20 miles per gallon, and you pay $3 a gallon for gas, which maybe you can in some parts of the country, you sure as hell can't where I'm sitting. Nevertheless, if you got a 9% improvement in fuel economy, you would save $1,600 a year. So I would ask you, what would that oil change be worth to you? And we'll just leave that there. But for people that are looking at this, so Matt Hartford had a very successful this year in NHRA Pro Stock for a single independent team. But for a lot of us, yeah, he did. So for a lot of us that now this time of year is time to go through our combinations, do some upgrades. I'll admit freely, I'm holding my hand up here as a guy who's going through the motor, going to put some Total Seal AP rings in. I've been working with Kevin Studiker for a long time, so he's my source for that stuff. Yeah. When people are looking at going to these newer, more technical rings, ring packs that are developed for, maybe vacuum pump engines or maybe turbocharged engines, which a lot of our listeners are into, what are they supposed to be thinking about in terms of ring pack and oil, especially for break-in and then running the engines? And I know that's a compound question, but that's my job here, is to ask compound questions.
No, that's good. That's a great question. So let's start off with just some perspective. And I have to give some credit here to a guy named Larry Wallace. And hopefully everybody that's tuned in and listening may know who Larry Wallace is. He was the head engine builder at Penske back in the mid-'90s up through the 2000s. In fact, the first NASCAR engine that ran 9,000 RPM plus intentionally, not because of a missed shift, was Larry Wallace's engines. He's one of my heroes in engine building. He told me one day, he said, Lake, it's real simple. If you go to Mount Everest, all the dead bodies are at the top of the mountain. They're not at the bottom. Because the higher you climb, the less margin of error you have. Right? Just let that sink in for a minute, because that's something I think we can apply to a lot of things, in engines and in life in general. That as you climb horsepower, as you get more advanced in your volumetric efficiency and your, horsepower per cubic inch, your margin of error gets smaller and smaller and smaller. So to answer your question about, okay, yes, we went from an 0.43 ring to a 0.9 ring, and that wet sump engine, it picked up 10.5 horsepower. What I didn't tell you is we also went from that 0.9 to the 0.7, it picked up 12 average. Now that's going from an AP ring to a diamond finish ring. That's a really expensive ring, but it's 12 horsepower on a 450 horsepower engine. And that's 12 average, not 12 peak, right? Now, the trick is when you do that, now your break-in does become critical. And, obviously I'm hugely biased towards driven oil because that is my baby, right? There's no doubt about it. I formulated all of those products, but I also believe in them. We tested them that when you get to those kind of ring packages, you have to be running a dedicated, specific break-in oil. And it needs to be a low detergent break-in oil. Just because it says break-in oil and high zinc does not mean that it's going to be good for piston rings. Because there's a lot of oils out there that were developed for flat tappet cams that will not work. Like in our example before, when the thing was oiling, yeah, great cam, terrible on the rings. And the trick is calcium. There's a lot of oils you can find, used oil analysis, or they call it virgin oil analysis, VOA, on the internet. My daughter's company publishes a lots of them. You can go to Speed Diagnostics and see the samples results for free. She's not trying to sell you anything, she's just giving the information that show the calcium levels. You want something with under 1,000 parts per million calcium, ideally. You definitely don't want something with more than 2,000 parts per million calcium. You do not want moly in the oil at all. And that's the best guidance I can give you. And, as a company at Total Seal, we will be coming out with some guidelines for break-in oil. We're not gonna pick and choose brands. We don't want to sit there and say, okay, well, because Lake came from Driven, then we're going to say Driven is the only oil. No. We will never do that, because our priority is our customer. Our whole mission in life, and you guys talked about it. Kevin, Keith, Bobby, and those guys. We're here for you guys. We're here for the end user. We want to help you be successful, and we'll make you whatever you need. So it's not our job to pick and choose winners, to pick and choose brands. We're just going to say, hey, our experience tells us that if the oil has properties like this, and we don't care if it's HPL, we don't care, if it's Schaefer's, we don't care if it's Driven, we don't care whose oil it is. As long as it meets these parameters, we're good with it. And that's going to give you the best results, because we're only good with it if it's going to work for you. We're just trying to keep you out of trouble is all we're trying to do. Because there's lots and lots of oils. I remember when we started Driven 15 years ago, there were 7 racing oils you could buy. I think the PRI oil issue this past year, I counted 20 something. I mean, there's just so many now. It's hard to make sense of, well, what's good and what's bad, right? Because some of them are there. I'm not knocking anybody, but some of them are there because they're there for marketing. Racing to them is marketing. They're not there to take care of the racer. They're there to use racing as a marketing platform to sell to consumers. And
hey, Lake.
Yes, sir.
I'm wondering if we can go back a little bit when you're talking about proper break-in, because you talked about oil and you talked about the ring package, but we did not talk about bore preparation or assembly lubricants and lubricant contamination or cross contamination. And you touched on, you don't want moly in your oil, but that everybody assembles their engine with molybdenum disulfite, do you want to talk about that a little bit?
Oh yeah. Thank you for bringing that up, because I can, as you can tell, I can squirrel and go down a rabbit hole pretty easy. So thank you for getting me back on track. Yes. So let's talk about bore preparation. And, really Keith Jones at Total Seal is the master of that. I'm not even going to try to give you RPK or RVK values off the top of my head, because it's late at night and I can't really remember it, and I'm not going to say anything. But those are the key numbers. And I know we at Total Seal have it, and I'm pretty sure both Rottler and Sonnen, I know Bob Dolder at Sonnen and Ed Keebler at Rottler. They're really experienced guys. They've done stuff with everybody. You can get a hold of them. They can give you guidance on, okay, what are the RPK, RVK values you need? Because the whole thing is, you need that plateau finish, because otherwise, in my former life, I looked at, high peak values, because RAs doesn't tell you the whole story, right? You need to have RPK, because that's your peak height, and RVK, that's your valley depth. You need valley to hold oil, because oil is part of the seal, right? There's 4 things that create ring seal: the flatness of the ringland, the flatness of the ring, the bore finish, which needs to be that plateau, and the oil itself. Back in the early, probably 2006, 2007, somewhere in there, we all got in the NASCAR deal into the mirror bore deal. Well, the problem with mirror bore was there was no valley. We couldn't hold any oil. So blow-by went nuts, and you burned rings up because you couldn't hold enough oil at the top of the thing. So a lot of guys went to heavy oil to try to offset that. But the reality was you needed to have valley to hold the oil. So bore prep is key, and you need to have it clean. A lot of people that have micro-welding problems, the issues are, some diamonds, not all diamonds, some diamonds will leave the bore, the edges rough. And that's something we learned at Gibbs. At Gibbs, we would actually, get the cylinder straight and true and round with diamonds, because diamonds are really good at that. And again, with the NASCAR engines, that was compacted graphite, which is really a bear to hone. But then we would finish with vitrified stones. So we were using diamonds and coolant to get it round and straight, then use oil and vitrified stones to finish, to clean up the edges, and that helped us prevent micro-welding. Because all those little bitty bits, when it's breaking in, those little bitty bits get up in the oil, and your filter can't capture all that. So if anybody out there is having micro-welding problems, go back and really look at what you're doing in terms of your bore prep to make sure that, you may be in, if it's having to get, the brushes in there or something like that, to clean it up. That's what you got to do. And it goes back to what we talked about earlier. The higher you climb in power, the less margin of error you have. What you got away with making 700 horsepower, you can't get away with maybe making 900 horsepower. And the sure as hell, you're not going to make it making 1100. As you go up. Yes.
Sorry, I was just going to say, for some of our listeners, can you drop back a second and explain what you mean by the term micro-welding? Because I'm not sure everybody understands that.
Sure. So micro-welding is essentially when the ring welds itself on a very small space to the ring land. Obviously a piston's aluminum, right, in most cases, and then the ring is not. They shouldn't stick together because they're dissimilar materials, but sometimes they can. And that micro-welding is typically because there's a transfer of material between the two, and they stick together. And sometimes that's heat and things like that. But what we've found more times than not, that micro-welding, and it is more prevalent if you do not anodize the ring lands. But the trick is, when you anodize the ring lands, it increases the RA of the surface of the ring lands. Well, that increases the amount of leak. If you sit there, everybody's just listening, if you hold your hand up in front of you and spread your fingers out, that's what a rough surface is, peaks and valleys. Well, that gap between your fingers is a leak path, and also the other thing about there's basically 2 things that you can kind of learn from that analogy as you hold your fingers up in front of you, is that all those valleys are leak paths. If you think about, you put let's say you hold your left hand up and you hold your 4 fingers out spread, and you put your right hand flat on top of it, so it's, perpendicular to your fingers. That gap between your palm and the valley of your fingers, that's a gap that combustion blow-by can go through. That's lack of seal. That's going to cost you power. The number one source of friction in an engine is actually the piston and ring interface. And where you get the most blow-by, a lot of times is, one of those 4 leak paths. Either the ring land itself, the face of the ring, It's all around that ring is where the blow, and the ring gap obviously too, right? That's a big one. But not thinking about the ring gap. So there's two things, right? And you're holding your fingers up. That gap is blow by. The other thing is, think about it. All the load that's being pushed on that ring, right? You think about cylinder pressure. What that load is being pushed is now isolated on those tips. And those tips under that high pressure can weld. When you anodize the ring land, what you're doing is you're increasing the hardness of that land. So it makes it less resistant, or say more resistant actually, to welding. So it makes it less likely to weld, more resistant to welding, but the anodizing process increases the blow-by because it increases the surface roughness. The RA goes up. And we saw that at Gibbs, that, if we could run a piston with the ring grooves cut as is, and we used Bill Miller pistons back in the day, in our NASCAR days, when we were doing cup engines there, it was a 2 horsepower difference on a plate motor between an anodized ring land and an unanodized ring land.
Which I also
2
know is
horsepower
huge for them.
And a plate motor.
It's huge.
Oh, dude, you cut your arm off for that. You'd sell your mother for that, right?
Say along these same lines with the micro welding, what about heat transfer from the ring to the cylinder wall and the piston to the ring?
Same thing, right? Because that's the whole thing. That ring is the heat transfer path. The less contact area, the less heat transfer you get. So now from a tuning perspective, you're more likely to have a detonation issue if you can't get the heat out of the piston. So having better ring seal, and that's one thing that people, I think, sometimes, maybe falsely think, is that small ring can't conduct enough heat. Well, the trick is the small ring is more conformable. You actually get better contact. Yes, it's smaller, but if it has more contact area, if it's light tight the whole way around, it has better conformability. If you think about it, you think about a 5/64 ring, how thick it is. Think about a 0.7 millimeter ring, how thin it is. Well, you can't bend that 5/64 ring up and down very much. It can't follow the deviations in the piston, right? And we have to be realistic, right? None of this stuff in an engine is static. Everything in an engine is dynamic. Stuff is moving all over the damn place all the time. It's amazing the things, if you look at any FEA stuff, it's amazing these things can even run, right? Because everything's just moving all over the place. You'd think it would break. So the conformability of the ring to the land, as the piston's moving under compression and decompression and the stopping and starting and all that, that provides better ring seal and better heat transfer, because the more contact it has, the more heat it can transfer.
I'll confess,
I go back to
I never even realized that the ring's heat transfer out of the piston was a big deal, but it makes sense to me now that I think about it. You're trying to get as much heat out of the piston as possible.
And this is where you're seeing the piston oilers.
Oh yeah. I mean, that's why piston oilers are huge. I mean, it's you've got to get as much heat out of the piston as you possibly can. And obviously, when you go to a smaller ring, you reduce friction. You reduce wear. That was one of the things that we found. Actually, I kind of looked the other day. It was kind of interesting. For anybody that follows me on Facebook, I put up a lot of stuff. I just kind of throw stuff out there on my personal Facebook page as I'm testing stuff. We had this, small block Chevy engine with the 0.7 millimeter rings in it. And since the last ring swap we put in it, it's a flat tappet motor, small block Chevy. We've got about 353 pulls on the dyno on that engine. And then we've got another, which is the CT525, which is the crate motor from GM, which is an LS3 based engine. And it's got, the OEM, 1.2, 3 millimeter oil control ring, right? OEM package.
Right.
It's got about 350 something pulls on it. And I looked at the oil analysis data on it. when we run the same oils, and every oil we run, we pull samples. And I looked at that, had this exact same oil in the exact same, or in these two engines with the exact same amount of runtime on the two oils. And I looked at the oil analysis, and the wear metals in the flat tappet engine were half of what we saw in the roller cam engine. Yeah, half. And from a flat tap, it was less than a roller cam engine. The difference is the ring package. And then we went and did a leak down test on the engine. We were like, wait, hang on, that's weird. It can't be the bore. I mean, it couldn't be, right? We go leak it with a 0.7 millimeter ring engine. It's leaking 6.5%, 6.7 to be exact, right? Average of all 8 cylinders.
Is that cold?
The CT5, that's hot.
That was hot. Okay.
That's hot, right off the dyno. The CT525 leaked 11% hot right off the dyno.
When
the portions are pretty close.
When you're talking about wear, are you talking about the ring wearing, or are you talking about the cylinder wall itself wearing, or a combination?
Both, right? I mean, both, right? Because the oil analysis picks up iron, and the problem with the limitation of oil analysis is it's picking up individual elements. It does not pick up compounds, molecules, right? So we know that a cast iron sleeve is going to be mostly iron, but it's going to have some other alloys in there as well. But what oil analysis is going to see is going to be iron. And of course, steel is going to have iron in it as well. It's not picking up the carbon content. It just sees the iron, right? So in this case, you got a cast iron block, you got a cast iron sleeve in the LS engine. You got steel rings in both of them. So we can attribute the difference in the wear levels is to ring/bore wear, which then correlates back to the difference in leak down between the two engines, at the same temperature and the same conditions, really translates back to that smaller ring wore the engine less, which is why it leaked down less, which is why after 350 hits, one engine's down, 5, 6, 7 horsepower average compared to the other engine, which is running the same numbers it was when it was brand new. And I can say that with confidence because I think back to the days at Gibbs, that was a big thing we did, is that we would do 500-mile race simulations. I was, again, the luckiest guy in the whole world because Mark Cronquist, at the end of every Cup season, would give me the 4 or 5 backup plate motors from the last Talladega race and say, I'm never racing these engines ever again because we need something better by Daytona in February. These engines are yours to do oil testing because you're my oil guy and I need more horsepower from my oil. So go find me something that can make more power. And the whole thing was we would make power runs we would break the engines in. Of course, they were already broken in, right? But the engines were broken in. You baselined them. You would run a 500-mile race simulation on your test oil. At the end of the 500-mile race simulation, you would rerun the oil with fresh oil. So it's not, you're taking the aging of the oil out to see what the condition of the engine is. Did the engine get better or get worse? And of course, what our goal was, we wanted to have more power at the end of the race, or at least not have less power at the end of the race. And we found over the years, we were able to work on different friction modifiers and packages that would make more power at the end of the race, and I look back now and say, well, a lot of that was the fact that we were running, in 2008, we were running 0.8 millimeter diamond finish total steel rings. That's small stuff. We've been doing that for a long time. That's nothing new, from the world that I'm from. Back then I didn't think about it. I never put 2 and 2 together until the last 6 months. And it was like, oh my God, I know what I'm going to do with my life now, so.
We do have a listener question, Lake.
Yeah,
and forgive me if you answered this because I've been answering private messages like a madman, but a Speed Ultra on Mixler wants to know, what is your actual suggestion for prepping the cylinder walls while the engine is during assembly? What is your actual bore prep procedure?
Okay, so my personal preference, what I like to do is once the engine comes out of the home, I like using a product called SD20. It's a foaming degreaser. It's water-based. You use that to dissolve all the residue and get everything out of the crosshatch. It's really, really good. Brake clean, and that other stuff won't clean it up as good because it's not really a solvent designed to dissolve oil. So use SD20 to get it all cleaned up. Then because it's water-based, you need to come back with WD-40 to get all the water out. Once it's clean, really cleaned up good, lint-free rag, and it's white, and everything's clean and white glove service and all the bores, then I like to come back with a little bit of BR30, lightly coat the walls with BR30 just so that it's just moist, right? It's not soaping wet, just so that it's not dry anymore. Then from that, we actually, I formulated and made the Total Seal AL8, their assembly lube, 7 years ago. And I think it's a great product. So I would use the Total Seal AL8 on the piston skirts and on the rings so that the rings in the lands are not dry. Again, back to the micro-welding deal. If people are having any of that kind of stuff, it's a big deal right there is to use that kind of product. It is synthetic. Don't let it bother you. It's okay to put on the piston skirts and on the rings and in the lands so that they're wet. And it's also really nice on wrist pins. I would put that together. And then essentially that's what you need to use to do the assembly. And then pick your brand, a low detergent, higher zinc formulation for braking oil, and then use that to break it in. Our experience at Gibbs, and of course we did, roller cam engines for the nationwide stuff and flat tap stuff for the Cup. We actually found that even for roller cam engines, we saw better leak down, better durability on parts overall, especially valve train parts, high spring pressure, push rod tips, those kind of things, by doing that 30-minute, 2,800 RPM, light load, probably, on a load controller, try to run it around like 15%, on the load controller in the dyno if you can. Just to put some load on the engine for that 20 minutes. At the end of that 20 to 30 minutes, it doesn't really matter because you're getting the oil hot. ZDP needs heat for it to work. It doesn't work dead cold. So you want to get that oil temperature up, 200 degrees, 200, 220 is really good. Don't worry. When I do the flat tap at Motor Deal, it's a wet sump. It's 265. Don't let that scare you. It's fine. As long as the viscosity is okay for the bearing clearance, don't sweat the oil temperature. If it's 320, there's a problem, right? But if it's 240, 260, don't worry about it. It's fine. Make a few, ideally you want to make two, part throttle, half RPM hits, right? Let's say the engine's going to redline at 8,000 RPM. Maybe you make some runs from part throttle from 2,000 to 4,000. Do a couple of those and then do a couple from say 3,000 to 6,000. And then do a couple from say 4,000 to 8,000. And you do that. By the time you're done doing that, with all that stuff done, it should be broken in. It should be sealed up. Even with, a diamond finish, dual steel ring that's going to be a little more tricky to get bedded in. But even with that process, she should be bedded in and should be really good to go from that point forward. Did I lose you? Hopefully not.
I'm here.
No, we're all here.
Okay, sorry.
Yeah,
we were just letting you go.
Oh no, there's all kinds of questions. I should have been watching all the questions on Facebook as it's going. So
we've got another question from Michael Rude, who's wondering how much wear difference are you seeing between tool steel rings and the AP rings in the same size ring and engine combination?
Great question. I haven't had a chance to do some back-to-back comparisons on that yet. The only oil analysis stuff I have that's back-to-back on the same oil, the same runtime, has been that OEM ring versus the diamond finish ring. So hopefully as I get, settled into my position here, we're going to do a lot more R&D stuff. That's one nice thing. My dad's got the dyno. My dad's old engine shop from his Cup days when we owned our own team. We still have the dyno cells in there. Of course, they've been converted to do go-kart engines. But I actually have a 4-cycle engine that's a double overhead cam, 12,000 RPM engine that came from Europe that we have that I'm going to use to do a lot of testing exactly like that. We're going to work with some piston guys and get some pistons done specifically for that engine so that I can do some testing exactly like that to test and do the oil analysis to see, okay, with this ring package, what's the efficiency difference? Like between that 0.9 and that 0.7 ring, both total seal rings, we saw a 3% increase in efficiency. So that's huge. 3% just by changing rings, is really big. But to quantify the wear difference, the durability difference, I need to do more work. Oh, Chris Stewart, I saw your thing. What about fuel during break-in? That's a great question, by the way. Essentially what you want to be careful of, and I was talking to a guy yesterday, actually, that was doing some diesel stuff. And, of course, the high-performance diesel stuff, a lot of those guys are running biodiesel, which has a lot of lubricity, and they've been having some break-in problems. And part of it may have been the oil. They were running really high detergent oil. But the other thing is when you're running a lot of fuel with a lot of lubricity to it, it's going to be harder for the rings to bed in. So I'd say be careful about overfueling during break-in. You don't want to wash the rings down. You don't want to dilute the oil too much. So there's a balancing act between having, so much fuel that you lose lubricity, but at the same time, you don't want a fuel that has so much lubricity in it that it's hard to bed in the rings. But I think you tend to be more on the side of it. You can be a little bit rich, but don't be too fat. Again, going back to my daughter's experience, that most of the engines that have problems have too much fuel in it. So just be careful about putting too much fuel in there. But I don't see any issue between methanol or E85 or pump gas or, 110 or 114 leaded. I don't see.
Can you define what too much fuel is?
On a Lambda, this way. Let's say you're running, like 110, like a late model plus, something like that. You don't want to be richer than 12 to 1, right? You obviously, that's going to be careful that you're not, I'll look it back on the oil analysis side that, you want to see samples that come back that are less than 2%. When you're getting samples back that are 3, 4, 5, 8%, you got problems. And typically, if you're going to be like when we did the 525, we were running around that 13.5, on break-in. That's fine. You want that's not too rich, to do that. But I'd say you could probably go into the mid 12s and still be okay on air fuel with a leaded type fuel. Obviously, when you get into methanol, E85, that's going to be different. But you can kind of take that same percentage basis and apply it. You just don't want to be too rich.
He's basically just saying unused fuel too, right? When you get beyond stoic and then everything else in there is excess for cooling.
Yeah.
I thought it was an interesting point he made a while ago. Go ahead, Mark.
And Steve Lick comes back with, can you shed some light on washing out the rings and how quickly can you do it?
Oh, you can do it in 10 minutes. If you're, especially like a mechanical injection engine, like a sprint car,
Yes, I've seen it.
My experience out at Ron Shaver's, right? When Don McCaskill fires up any engine they build, the fuel valve is at 50%. 50% on the valve going into the fuel system to break it in, you know, because he's like, I'm not going to make a wide open hit with the fuel valve, you know, closed that way, but I want to make sure during that first 30 minutes when they're running with some load and kind of cycling up and down that they don't overfuel the engine. So mechanical injection obviously is a much more difficult situation. But yes, ring washout can happen right off the bat.
How about after the engine's sealed up? Is there an issue after it's sealed up, after it's broken in, running too rich will wash them out?
Only from a bore wear perspective. It's not going to, once the engine's broken in and it's sealed up, then it should be good. The issue there is if you overfuel it, then you're going to end up hurting the oil, right? The oil film is going to be thinner. You're going to increase wear. Then you're going to, you know, that's what kills the oil, right? And your oil is what protects your engine. And so the more fuel you put in the oil, the less your oil can do, right? You're just diminishing what the oil can do in terms of its job.
Lake, we've had a question, Nathan Kaler posted this, and a lot of our guys, especially in the drag racing world, are asking more and more about either running, you know, pure alcohol or M1 fuels or E85 and similar things. Are there a difference in recommendations both around oils and around break-in procedures for cars that will ultimately be fueled on alcohol?
So, you know, at Driven, I wrote a chart that's still available on their website that is a recommended viscosity based on bearing clearance and operating temperature. And that's a really good tool to have, and it's available in the Driven catalog. And anybody that's listening, I would really recommend to go find it because it's generic. It's not specific to Driven products. That holds true for anybody's oil. So go get that, use that. Now, that is based on a naturally aspirated engine running gasoline. The rule of thumb is whatever that says, if you go to methanol or E85, go up one viscosity grade. If you add boost greater than atmospheric, go up one viscosity, which, you know, if you think about it, say for an engine that's got, you know, 2.7, you know, say small block Chevy, right? Let's just go back to the basic, right? Small block Chevy running 2.7 main and rod bearing clearance, right? Naturally aspirated, you're going to run with those clearances, you can run 10W30, no issues. All right, 2.5, 2.7 bearing clearance, 1030, you're fine. You know, pump gas, NA. You go to E85, let's say you go to methanol. Well, now you need to go up to a 40 grade. You put a blower on it, now you're running 2050, right? Everybody, we all know, right? What all the old school guys tell you if you're going to run methanol and you're going to run a blower, where you got to run? Oh, you got to run 2050 in that thing, right? You got to run about, 2.5, run 2.7, 2.8, somewhere around there, almost maybe 3,000 bearing clearance. Well, it all makes sense, The old school guys weren't dumb, They figured out what would work. They may have not have known why it worked, but they did know what worked. And the reality is if you were running, 14 pounds of boost, on an old Whipple supercharger, and you're running methanol, and you're running a 400, style mains and rods with what you had for cranks back then, you had to run 3,000 bearing clearance, and when you had that much bearing clearance and that much flex, you had to run 2050. So that's what they did, and they all ran Kendall GT1 because that was the best stuff you could buy back in the day. They didn't know why, but they just know it worked. Well, today I can tell you exactly why that worked. is because they had to have that much viscosity based on those bearing clearances, based on the flex of that crankshaft, based on the speeds and the loads. And by the way, that old 2050 that was from Kendall came out of Bradford, Pennsylvania. And the Pennsylvania-based crude oil, just that stuff out of Pennsylvania, had the best wear protection of any other crude source on the planet, like by a lot, like 30, 40% better. That's why they all ran it, because it worked. So those are just some things you look back and you say, that was one of the things I always wanted to do. And I'm always interested in the why. It's cool that if I find an answer that, okay, I got the job done. Okay, great, job done. Why did it work? Just the why that it works is what wakes me up at 2:00 in the morning thinking about.
Yeah.
I
Sometimes that's the worst part. Yeah.
Oh God, it is.
I have that same problem.
You throw a spring in the car.
Everything was fine.
Well, yeah.
Yeah.
Why? The why is what tortures you. I'm talking too much. People need to ask questions.
No, you're doing fine. I'm popping off the answers to questions.
We built up
a
nice backlog here, so not to worry. So you referred a little bit ago to AP ring. This is specific, obviously, to total seal, but AP ring versus the diamond rings. How are you, and I realize you've been in the job formally for 3 days, but as you've explained, you've been intimately involved in this interface between ring seal and oil and all these things for a long time, so we'll presume upon your knowledge. How should people be looking at making decisions? And if we can dial back a little bit, because we've got folks on here doing the classic stock bottom end LS rebuild where maybe they want to re-ring it, and they're going to run a single turbo and push, I don't know, somebody on here knows turbos talk more than me. They're going to push 1 to 2 atmospheres through it or something like that. Mm-hmm. Versus people on the ragged edge, of crazy high RPM NA motors. What do they need to be thinking about in terms of ring selection, especially now because we've moved to these thinner and thinner rings, and yet a lot of folks out there are seeing a piston package somewhere and it's got good old fat thick rings on it. What are people looking for, and what are the gains to be had as you sort of go up the scale from a driver to a more race focused engine to something that people is mostly going to race, maybe drive a little bit, those types of considerations that represent frankly the vast numbers of consumers, especially in our audience?
Sure, that's a great question. So when you're looking at, say, the classic LS swap, which, by the way, someone needs to LS swap a damn Tesla and put a damn blower or turbo through the hood. Please, dear God. It's time to get revenge. Please, somebody. Twin turbo. I went to LS Fest this past year. It was awesome. I was in heaven at LS Fest. But I digress to answer your question.
It's in the works.
It's in the works. Bewley's on it.
It's in the works. Yeah.
If somebody's doing it, Bewley knows about it.
Yeah,
that's awesome. I love it. Please.
You can go to sleep tonight, rest well, knowing that there is a Tesla in existence right now that has an internal combustion engine from the LS family planted between its front fenders.
Oh man, I can die now. That's good. All right, I can pass away. That's awesome. So anyway, to answer your question about LS engines, so if you're doing the stock bottom end deal and you're doing if you're using the factory piston, right? Well, then there's some options, right? Obviously, with the factory ring groove, then you can either do one of two things. You can put in a ring that fits through groove, right? And there's some, from say like an AP ring or something like that, or a diamond finish ring, which is, let's be honest, if you're running a stock bottom end engine, you're probably not going to want to spend the money for a diamond finish ring. It's really, really expensive. It's a great ring, but it's going to be really, really expensive. An AP ring is going to be more cost effective for you. it's a flatter, smoother ring, which is going to be great.
Define really, really expensive.
Something along the lines of about $700, $800 a set. So you're over $100 a hole versus $100 for a whole set.
Is that what Total Seal calls their M2?
I think that's different. Again, I'm not here long enough to really know. My experience, personal experience, has not been with the M2. Mine has been with the AP and the diamond finish.
Okay.
That's my personal experience. So that's the stuff I know. The other stuff I don't know yet.
Because I've got 4 engines now that I've got out in service that have the M2 style ring in them. Mm-hmm. They're big, they're fat, they're designed to handle 3,000 horsepower, and I plan on putting them to that test. So the price point you mentioned was about the same as what I was into those for. So I was curious if that was the same thing.
Right. So I think, and this is me just pulling crap out of the air, just full disclosure, the M2 tool steel, being the name that it is M2 tool steel, tells me that it's made from the same material as the diamond finish ring, which is also M2 tool steel. I believe what they're doing with those is they are making them a bigger, stronger ring in order to handle the higher loads, right? The diamond finish stuff is what we were using in the naturally aspirated stuff, because it's tiny and it's compliant and it can do everything you want in a really high revving, naturally aspirated engine. Whereas the M2 tool steel line, I do believe you are correct. That is made for the, oh my God, how much boost did you say you're going to run? Yeah, we got that.
60.
You're good. Don't worry about it. We take care of that. Yeah, exactly.
When you tell them the atmospheres is going to be approaching double digits and the motor won't even get started unless it's got a 7-bar map sensor in it. Yeah, he said this is the one that you need to use in that.
Yeah. So that's the great thing is that there's guys named Kevin Studaker and Bobby Cheeseman and Keith Jones that you can call at Total Seal, and they know all this stuff like the back of their hand. And they do this all day, every day. They work with everybody. They know this stuff. So don't hesitate. Anybody, don't listen to me. If you got an application and you need an answer, those guys are the pros, and they know it. Like I said, like the back of their hand. They can tell you what ring package to do and all that. But to kind of go back to the general question, if you got the stock piston, then you're stuck with a stock ring, right? And you can either run, one of our products that fits that ring, or one of the really cool things, if you really want to make some power and you want to have that better durability, we've got the spacer rings where you can take that same, you don't have to have an aftermarket piston that custom made to fit the smaller ring. You can put the spacer in there and then use the smaller ring with the spacer. And in fact, we've got a incredibly cool gas ported spacer. So now you don't have to put gas ports in your stock piston. You can basically put the gas ports through the spacer and run the smaller ring with the factory ring space already in there. So that's really awesome. And apparently that's huge in like some of the factory stock classes, like the factory shootout stuff now, where you can't change the piston. What they do is this is the factory land. You can't change it. Well, we're still putting 0.8 stuff in there that's gas ported, but the piston's not, but the ring is. Because you got a gas ported spacer.
So to clarify, the spacer essentially looks like what you would normally have with lateral gas ports on the ring lands, and puts that lateral gas porting into the smaller thickness ring. So you get the benefits of a thin ring with lateral gas ports, with that support in a conventional larger ringland, because you're mandated to run a stock, we'll use that term, style piston. Is that what you just said? Because that sounds pretty
Yes, sir. That is 100% it. Oh, it's really freaking cool.
Oh, yeah, that's awesome.
Yeah, it is. It's really freaking cool. I say, now do you guys know why I left Ribbon? Y'all figuring that out? I mean, I love oil, but this stuff is way cool. And by the way, that's a ring that is coated with anti-friction coatings. It's awesome. Oh yeah, it's good stuff.
That's neat because that opens up for a lot of people a world of much more affordable pistons with a more sophisticated ring pack as a way to deal with, when you're looking at sort of total cost of ownership, or at least total cost of assembly, or some phrase like that. That's great.
Right.
So that just means you got to be talking to your engine builder, or when you're spending time with LJMS, or you're spending time with some of the other guys that are here that can help you with that, crass commercial post for the guys here who host this show. Yeah.
I don't know about all that, Bill. That sounds like some NA stuff. What in the world are you talking about with all that?
Bill's a motor breathing atmospheric pressure. What?
Jeez.
Yeah, I know.
What in the world?
Sorry, we're having a little head down the rat hole of our own here, Lake.
That's all good, man.
Yeah, I this is funny. I'm the guy that's used to paying $800-900 or so for rings because I'm in this 4, 6, 4, 7 bore world, as opposed to that little piddly ass stuff everybody else does. So never mind.
I need that.
The little
I'm 4604 over here. I'm just saying.
The little piddly ass shit that outruns.
I was
you
gonna
by
say.
how many miles an hour?
Right.
Yeah.
That's all right. All motor guys, I'll never
Get
quite
me
understand
a
them.
couple of Jose's on there, and we'll see who outruns who. Anyway,
back the classic
to Lake.
battle right there, right?
Yeah.
I'm always fascinated by all those guys at the deep end of the pool running, Radial versus the World, or the guys running Unlimited at Drag Week, or whatever thing you want to pick. And they're all running little small blocks, right?
Some of them are, but
no, they're not. Give me a break. Anyway,
yeah, you're not running 240 in the 8th. The small block.
So back to our
for
regularly scheduled program.
I actually just have a quick question that Brandon Smith posted up here for Lake. Are you giving a presentation at PRI next week?
I am. So I think it's the last time slot on Saturday. I think it's like from 3 to 4 on Saturday at PRI. I am doing a talk for PRI. Yes. So if anybody is listening that's coming to PRI, please come. Because I was like, I didn't even realize the time slot was like 3 to 4 on Saturday. I'm like, is there anybody even at the show at 3 to 4 on Saturday?
For sure.
If you want to come talk about oil, please come by. I would love to chat.
We will fill that show for sure. Everybody show up at Lake Speed Junior's PRI presentation Saturday. Saturday at 3 till 4.
It's Saturday from 3 to 4. Yeah.
Perfect.
They'll be when you get to
there.
PRI. They're going to have their PRI education thing, and you should be able to find all the different seminars that are part of the PRI education piece on there. Then you'll find me down there somewhere.
I'll come sit in on that. Why not?
Yeah, for anybody who's attending PRI, they have made amazing strides with the app that you can download for free to find out where things are, whether it's a booth or where the educational events are. So if you have a smartphone, and God help you if you don't, if you have one, download the app when you get to the show. If you want to find things and find where people are and figure it out, it's the bomb. They used to suck, but they're amazing now.
Yeah.
As long as we're on PRI, can I say something?
No.
We've got all these manufacturers there with people like Lake Speed Junior and all their tech guys there to answer questions and show you their latest product and what they've accomplished in the last year, what the newest, latest, greatest thing is. don't be the guy that goes booth to booth asking for something for free. They see thousands of people every day, and every single person wants to be sponsored or wants to have something from them. Just don't be that guy at PRI. If you think you need a sponsorship, contact them later. Don't do it at PRI. It's
Amen.
really a struggle for the guys to get through all the people that legitimately need help and have legitimate questions when someone's sitting there talking about their... What's that?
I said that want to pay for product.
Yeah, or that need help with product they've already paid for.
I can tell you, as somebody that's been doing this for a long time, when people ask me, okay, should I go to the show as a racer, enthusiast, or whatever, I always say yes. I said, but don't bring your proposal with you. Go there to meet people. I mean, I will go out of my way to help somebody in terms of, answering emails and text messages. I mean, a bunch of you guys, y'all know me.
You're awesome at that, man.
Right?
Thank you. Even the littlest guy will get a response from Lightspeed. Yep.
Right. I mean, it may be at like 8 o'clock or 9 o'clock on a Saturday night. I'm sitting. I mean, if I get a message from somebody and you ask me a question, I'm going to get back to you. Right. And the thing is, I will do that for somebody. This has a legitimate question. If you send me a sponsorship proposal, dude, you're going straight to trash. I'm sorry. And it's not because I don't understand it. Trust me, my dad, right? He was a racer for 20 years in NASCAR. Sponsorship pays the bills. I mean, I totally get the need for sponsorship. I do. But as a manufacturer, I can't do that. I can't give away product because I have suppliers that don't get sponsorship. I've got employees that have to get paid, every other Friday. So when I make a product, we have to sell it, especially a racing product. It'd be different, I relate it back to my time at Driven. If ExxonMobil can come in and give away free oil in any series they want to, because they're a huge multi-billion-dollar global corporation, and racing sponsorship is just marketing investment for them. They don't have any care about it, but a set of piston rings, we don't, Total Steel's never going to be selling piston rings, to mom's minivan. It's not like a housewife is going to say, you know what, I need to go get some Total Steel piston rings in my minivan today to get that 9% fuel economy. It's never going to happen, right?
What a great analogy. So, no, you're right. It's a race part, man. Some parts you just got to pay for to have the good stuff.
Right.
Yeah.
And you know what? Hey, we've got everything from, Claimer series set of rings, kind of like, we had XB4 at Driven, right? It was the cheapest oil we made. There was still a good oil, right? And then you had, at the high end, you had XP1 that was $20 a quart. We've got diamond finish rings, which are really expensive, and there's a value, right? So that higher end product does things the lower end product doesn't. And there is value in that. And the whole key thing is, I heard somebody say the other day, when you start off with your project, you need to think what's the end goal? What am I trying to accomplish? And then let that be the determination of what I need. Because if you just go try to buy the best of everything, the chances of it all working well together are going to be garbage. I mean, it's hardly ever going to happen, So it's all about really beginning with the end in mind and then working backwards from there to figure out what parts you really need. And, should I invest in better oil or not? Should I invest in better rings or not? The good thing about, oil and rings is that, it's a direct effect on the efficiency of the engine. If I could share a slide, I would. There's a slide I have in the presentation. Actually, you know what? Because of everybody being on here talking, I'll make sure I add it to the slide for the PRI presentation that actually shows from the energy potential of the fuel going into the engine, right? So basically, that basically takes out the volumetric efficiency and kind of takes everything else out of the matter, right? If you look at the energy potential of the fuel that goes into an internal combustion engine, any guesses from you guys on how much of that actually reaches the tires?
I guess 30%.
Potential.
20 to 24%.
10%.
Wow. 10% of the thermal units, right?
10%.
BTUs? Yeah.
Yeah. If you take your BTUs and say, okay, that's energy potential, how much of that actually reaches the tires?
I believe that.
10%.
Because a lot of people are
here's the
thinking
deal.
flywheel numbers, and really you got to think about all the heat loss to the powertrain and everything else. You're heating up an awful lot of shit with those BTUs. That's not power at the wheels.
Especially if you got an automatic transmission, oh my God, it takes so much power. It's stupid.
Yeah.
I think that's going to depend greatly on if you're on a hub dyno or a roller dyno.
Well,
that'll be a
I'm getting my
factor, too.
numbers from the hub dyno.
He's talking
Right.
about the tires on the real road.
I'm just teasing. We do
No,
have
but like
a
Mark,
question.
like Tom said, go ahead, Mark.
We do have a question that we missed earlier, Lake, and you had touched on, the old Kendall GT1 green oil, which became Brad Penn and now is Penn grade. And Driven has introduced their new GP1, which is a green oil also. How does the GP1 oil compare to Penn grade, especially if you're a methanol turbo application? Keith Ria wants to know.
So the situation is GP1 is the only oil currently being made in Bradford, Pennsylvania at the original Kendall refinery. Penn grade is now owned by D8 Lubricants. It's not owned by ARG, which is the company that owns the refinery in Bradford. As of about 18 months ago, maybe a little bit longer, DA Lubricants moved the production out of Pennsylvania to Indiana. And this isn't hearsay. This isn't throwing mud at anybody. You can go look at the MSDS sheets from Penn grade. They are not using 100% Pennsylvania base oils anymore. It's still green because they put green dye in it, just like we put dye in our, Driven. Still struggling with the pronouns, you guys. A couple of days still.
It's okay.
Driven puts blue dye in. Thank you, appreciate it. Driven puts blue dye in the oil, but the GP1 is the same base oils as the original Kendall GT1, as the original Brad Penn product. It just has a driven-based, driven formulated additive package that contains the same additive technology that we used, to do the stuff for Joe Gibbs. There, I said we again, stuck in my ass.
Well, when all of that was done, you were part of it, so that would still include we.
Yeah, it was me. Yeah. Back then, it was we. We did a lot of work. The GP1, I can tell you right now. Obviously, I don't have any. I benefit zero from saying this. In my opinion, the Driven GP1 is the best oil anybody can buy on the planet right now for a performance engine. I was literally blown away by the performance of the Pennsylvania product. If you'd asked me 15 months ago what I thought of Pennsylvania oil, I would have said, well, that's leftover heritage from Castrol, or say not Castrol, but Pennzoil and Quaker State spending 100 years advertising Pennsylvania. That there's nothing special about Pennsylvania base oil. It's just marketing value. That was before I actually started doing wear testing and oil development using the Pennsylvania base oil. Then I was like St. Paul. I had a Damascus Road conversion experience where we did a test and literally all I did was change the base oil. I changed nothing else. The additive package was the exact same. I ran the same test we run all the time. We would do this flat tappet wear test. Now I would send Billy Godbold from cop cams to cams, and he would measure them. He would send me back the report, and I got back the report, and I was like, all right, Bill, we got to do this test again. There must have been a mistake because that number's half of what it normally is. And Jake, by the way, I am watching the part. Yes, dye is marketing. We just put color in it so that it looks different. That's all the reason it's there. It doesn't do anything other than for marketing purposes.
We do have
there's nothing special about green. But anyway, so I was trying to say is that this stuff was it was so good. We repeated the test 3 times, and it repeated itself over and over again. That there's something special about Pennsylvania base oil. That's why Kendall became popular. I always thought it was just because Big Daddy, Don Gartlitz was sponsored by Kendall, and he was the baddest drag racer on the planet. And I was like, okay, well, that's just why. But the reality is the stuff works because the Pennsylvania base oil is actually better. In terms of wear protection.
Stangman 68 on YouTube. We're going back to rings now, Lake. We're bouncing around a little bit, but he's wondering what are the advantages and disadvantages to running a Napier second ring?
Okay, great question. So really, when you think about it, in a 3-ring package, you got a compression ring, a second ring, and an oil control ring. Well, 80% of the compression sealing is done by the top ring. 20% of the sealing is done by the second ring, which means the second ring is primarily an oil control ring. I think that Bill McKnight came up, was at Mala. I think he came up with this phrase that the oil control ring is gross oil control. The second ring is fine oil control. It's kind of like if you're painting a wall, you use the rollers to get the bulk of the wall done, but then you use the brush to cut in the edging. That second ring, that Napier second, is a precise, really high quality paintbrush to cut in. And that Napier second is what really gives you really great oil control. And in fact, you need that Napier second when you start running a smaller, oil control ring, lower tension, because it really makes a big difference in assisting, which is why pretty much everybody at the high end runs a Napier second.
For those of our folks who aren't familiar with the shape of the Napier second, can you describe that a little bit for folks, just so they kind of, can picture this? Because it's definitely an unusually shaped ring compared to just sort of conventional stuff.
Right. So, if you imagine a ring, the face of the ring, the part that actually touches the cylinder wall, the typical top ring is actually a barrel shape. It's not flat. And the reason for that is the piston isn't always vertical. It has rock, so when the piston moves, kind of back and forth, that barrel on the top allows it to maintain contact and seal. Okay. The second ring, the Napier, or the bottom, if you imagine the bottom of the ring has a hook on it, essentially, right? That's basically, it doesn't extend out. It's basically cut in so that it's got this hook that's basically scraping the oil off the cylinder wall. That way you don't have excess oil consumption. Because as if you remember from the last time we talked, right, what causes the low-speed pre-ignition is the presence of oil in the combustion chamber. So oil control is huge because you don't want oil on the top side of the piston because it has a lower octane value than the fuel and can cause detonation. So oil control is huge. And a Napier second provides better oil control.
When you get into the ultra-thin rings, do you have room to put a Napier in there without making the ring too weak?
Yeah, even on our 0.7 millimeter engine, that's the wet sump. It's a Napier second.
And then Rory
you can
Somerville.
See the tools, how tiny the tools are on the CNC machines at Total Seal. Anybody that's been around CNC machines a lot knows that there's when the coolant comes out, you'll have the big drag outs that pull the big chips out. When you go to the ones here at Total Seal, there's no drag out because the chips are so fine, because we're using so tiny tools to do that work. It's amazing.
How high pitch is the noise when they're cutting?
Oh man, it's amazing. It's like a symphony. I was watching one of the new machines run yesterday. It's like, damn, it's like a Formula One car running at 20,000 RPM. It's great.
Rory Somerville is wondering what's your opinion of Formula One tech and I'm not sure about this. I'm sure you know, but what is your opinion on Formula One tech of power boosting using the engine's oil?
Okay, so all right, that's a great question. So you got to remember the big picture here. So Formula One, when they went to the current power unit, is what they call it, right? And what led to the using oil to aid combustion, right? We got to kind of take a step back. There's a fuel flow limit. So there's an inline real-time fuel flow meter in every Formula One engine. And FIA, who oversees Formula One, monitors fuel flow in those engines, and there is a maximum fuel flow, right? So going back to our discussion a little bit ago about
they're limited by
and,
rules.
okay, there's so much. Right. So essentially, if you're limited to, let's just say for round numbers, 100 gallons per hour of fuel flow, well then that limits how much power you can make. So some really, really smart guys realized that fuel is a hydrocarbon. It's a small hydrocarbon, and you just got to think about hydrocarbon meaning that it's a molecule that's made of both hydrogen and carbon, and typically it's a linear molecule where you've got, the higher the carbon count, the longer the chain, like Legos, right? Let's think about this not as chemistry. Think about this as Legos, right? And when you're a kid and you're trying to build your Lego thing and you need an 8-brick Lego and you don't have one, what do? You take 4 2s and you put them together to make an 8.
Right.
Or a pair of 4s if you got them. That's even better, right?
Sure.
So that's what you're doing. So and these aren't real numbers, so don't quote me on that. Let's just for the sake of fun, let's say fuel is a carbon 8. That's how many carbon atoms are in a single molecule of the fuel they're using. Okay. Oil is also a hydrocarbon. It just happens to be a much longer one. So let's say the fuel is a carbon 8. Fuel might be a carbon, or oil might be a carbon 48. What the really brilliant engineers in Formula One realize that if we're limited on fuel flow, we're not limited on oil consumption. And if we put some C10 molecules in our oil that have a high vaporization rate, and then we design our piston rings and our pistons so that they actually deliver oil to the combustion chamber, and we design our oil to be more like a 2-stroke oil as opposed to a 4-cycle oil, then we can add more hydrocarbons to the combustion chamber and thereby have more fuel.
So instead of keeping oil out of the chamber, they did the exact opposite and pushed it into the chamber.
Yes. Yes. And I can tell you for a fact that when I went over to England in January, and I had a chance to speak with someone that was 100% in the know, and we had a chance to kind of speak kind of off to the side, I asked him, I said, so oil burning, this is my perspective as an outside person that happens to know a little bit about fuel and a little bit about oil. And your regulations, is this what you were doing? He said, oh, 100%. And he said, that's exactly why we did it. And some teams did it more than others. They actually would start a race with over 20 gallons of oil in the car because they would consume so much oil during the race.
Did he say how much power they picked up from that? Was like 1 or 2%?
He didn't say it, and I didn't ask. I was just more curious. Okay,
I mean, that's all it needs to be.
I heard about it, and I recognized it. But the thing about just the more fuel you put to it, the more power you can make. If you watch some of the races, I think it was like the Bahrain race maybe 2 years ago when you were watching the Ferrari cars. You could see the oil coming out of the exhaust going down the straightaway. And in fact, the in-car camera, the drivers behind them, kept on scrolling, the windshield visor thing on the camera kept on scrolling because it was getting clouded up with oil. That gives you an idea of how much oil they were using.
More power, and
which to me is brilliant. I love that.
Yeah.
To me, that's what motorsports is all about. I hate spec racing. I hate Teslas. Yeah. I hate all of that stuff. I love, hey, you came up with a rule, and we figured our way around it, and we kicked your ass.
Yeah,
that's racing.
And we raced the rule book, not each other. Fun. That's what makes it fun for engineers too, right? Yeah, I hate spec classes anymore because I'm not allowed to participate. Really, I want to be able to use my brain to do something and work around the rules as well. So, yeah.
Did you hear the part about the rings with the spacers and the lateral gas ports and the rules? I'm just asking because
someone's paying attention.
Yeah.
Anything you can use to, hey, listen, physics works both directions, right? It's that good old Sir Isaac Newton, things work in both directions.
Right. I tell you that at Bonneville too on the rookie orientation, except it's the throttle works in both directions.
That's another great place. I love Bonneville.
Oh, I do too. Yeah. Let's see. Any other questions here, Mark? You see anything? Go ahead, Bill.
I saw a question that I'm a little confused by on, but again, that's just me on the good Lord, Bill. What is this damn thing called? I've got so many windows open here. I'm trying to figure out what this is on YouTube. A question about lapping piston rings prior to installation help with break-in. I'm not familiar with that.
Okay, so one of the things that, like when we talked about the AP and the diamond finish rings, one of the things that we, at Total Seal that we've actually patented is one of our proprietary technologies, is a lapping process where the flat part of the ring, right, the part that actually sits, on the ringland, that lapping process, going back to what we talked about earlier, holding your finger up, you take your left hand, hold it up and spread your fingers out. Anytime you grind something, anytime you cut metal, there's going to be peaks and valleys. The idea of lapping is just like the idea of plateau honing, is to smooth those out so that you take your fingers and you bend them down, right? So that you bend them at your knuckle. What happens? It goes flat. Those valleys go away. Those peaks go down. That's the idea of lapping. So, it's kind of like it's a lot easier to do push-ups on your palms than your fingertips. The idea of lapping is that now you're smoothing those faces, the vertical faces, not the horizontal, but the vertical faces of the ring. You're lapping them, you're smoothing them. So now you get better seal, better contact area, which we talked about earlier, not only provides better heat transfer, but also better sealing as well. And we do the faces as well. The lapping of the faces is so that the ring is already broken in. And really, I should have mentioned that earlier when we were talking about break-in. One perspective everybody should take away. When you're breaking in a new engine, especially breaking in new rings and a freshly honed bore, you're not breaking in the ring what you're doing is you're finishing the honing job. Because the rings, like if you buy one of our rings from Total Seal, they're all pre-lapped on the face, which means they're already broken in. What you're finishing is the hone. You're taking those peaks on the hone. So what break-in oil is the last metalworking fluid, the last honing oil, if you will, that goes in the engine before you put regular oil in it. And I will tell you, because now I don't work there anymore, is that the original formula of the Joe Gibbs break-in oil had same or similar additives that are also used in honing oil. It was like a hybrid between honing oil and motor oil. That's what made this stuff work so good.
The piston and the ring to really hone the cylinder. The ring wears the cylinder down?
Yep, that's what's happening. Especially when you're talking about the tool steel ring, back to John's thing, right? When you've got that tool steel ring, you are not wearing a tool steel ring, especially one that's coated. That ring ain't wearing. It ain't happening. What you're wearing is a cylinder, and you're finishing the honing.
I have a question for you, and it's kind of a broad question. Goes to oil or piston rings. What do you see the average shop, average enthusiast? What's the biggest mistake or the most common mistakes you see them making?
Oh, from my last 15 years, my experience is that people think that if I have a flat tappet cam engine, well, obviously I need break-in oil, I need high zinc, and they've educated themselves for the most part. But if they have a roller cam engine, they just say, I'm just going to go buy oil and put it in it. And that they miss the advantages, the potential gains by properly breaking in the engine using break-in oil. That's the biggest thing in the last 15 years that I've seen, is that you got that junkyard LS with the stock bottom end, and you're going to put twin turbos on it and all that. But you've rehoned it and you've done some of this stuff and that, cam swap and all that. All those new parts need to be broken in. Yes, you can put in oil from Walmart or from O'Reilly's and run it. And it might say high zinc, it might say racing oil on it, and it might work. Well, what does work mean, right? I mean, a real common statement, and I'm not picking on anybody. Please know I'm not acting like I'm God Almighty and I know everything. Because listen, everything I talked about, making mistakes, I've made myself. I mean, I've wiped out cam bearings, I've flattened camshafts, I've done everything stupid wrong that anybody else has done. Trust me, I've blown up my go-kart motors with my dad by having them too lean and not paying attention. I'm not perfect, so please don't think that I'm talking down to anybody. But what I see is that when someone goes to that roller cam engine, they just put regular oil in there and they just run it. And they say, well, I've had good luck. I haven't had any problems. Well, what does that mean? When you say good luck, it means you don't have a box full of broken parts. That's all you're talking about, which is akin to saying, you know what? I didn't fail that test in school, therefore I must have made an A. Well, you might be a D student and just don't know it. Because you didn't fail, you didn't have bad luck, right? And that's the problem. That's the biggest thing I see, is that and it's no one's fault, because if you don't have the tools to do the kind of measuring, then it's hard to know.
So it sounds like,
well, it didn't blow up.
Yeah,
you need to have tools.
It sounds like that people it worked, so it's good, it passed. They don't know the difference between good and great. You know what I mean? Like, say 50% is their pass or fail, and they're getting 51%, and they could be getting 99%. They don't know the difference between.
Right.
I want to go back to the peaks and valleys, and that the break-in oil was like honing oil, because one of our listeners brought up, Jake Hildebrandt brought up that he had an engine, he put Hellfire rings in, and the rings wore his bores 5/1000ths of an inch. Now, I know that the rings didn't wear the bores 5/1000ths of an inch. I'm going to say that was a combination of improper lubrication and improper bore finish. What are your thoughts, Lake?
Well, there's a lot of different things, right? That could be, and it would be remiss of any of us to jump to a conclusion, right? I mean, one thing, okay, wait, and I've seen this happen before, is that if the axial depth of the ring groove, because that piston's going to grow, right? If you don't have enough clearance on the axial depth, then it can easily push those rings out. In a hard ring, it's going to cut more, right? So that's one thing we've seen. It very well could be an issue over fueling, could be, not having the proper viscosity or the proper, additive package in there to break in. There's a lot of different things that could cause that. As my buddy Keith Jones always says, that, the tire goes flat on the race car. Well, it was the damn ring's fault, Don't blame the ring first. You really got to look at all the stuff and find out what happened, because engine is a complex dynamic environment, and usually there's not one thing that's wrong. It's usually the perfect storm, because you think about it, a 4-cycle Briggs motor, the crankshaft can actually be broken if it breaks at the right angle, and it will still run. Doesn't mean it's good, but it will still run, because
Wow.
it's sheared off on an edge. And I've seen it before, where the crankshaft breaks right off the cheek on about a 45-degree angle with about a 15-degree twist to it. And all of a sudden, as long as that engine's running, there's enough load on it to keep everything turning. But once it stops, it'll never start again. But it ran, even though it was broken. I mean, I've literally experienced that in my life with a 4-cycle Briggs motor, because I've been racing go-karts since I was 4 years old, and I've seen some weird stuff. So, yeah, I'd say it's hard to answer this question. Just don't jump to a conclusion. You got to work through every single possible variable to find out what's going on. And my experience tells me more times than not, it's not one thing. Engines are pretty damn resilient. It takes a combination of things for something like that to happen.
So what you're saying is, realistically, he screwed something else up.
Jake
It's
Hildebrand.
trying to be nice.
No, Jake's cool, man.
Hey,
Not so
I'm
much
trying to be honest.
No,
Well,
Jake's
and
a
it's not
cool
somebody
guy.
that he
He's
screwed
funny.
something up. It's that. Well, it's not somebody that he screwed up. It may have been something that
Of course, but I just meant,
just a misfit or misapplication or something like that. That somebody sent the wrong size part, and and you don't check things. And I mean, I think we're all guilty of that at some point. Is that most of us are not professional engine builders that are working for a NASCAR or Formula One team or IndyCar team, where we get paid a lot of money to do one job, which is to check parts.
Right.
I mean, when I first came to work at Gibbs, there were people that their only job was to check valve springs. And every single valve spring that came in that building was checked by the same person. That's all they did, 10 hours a day, 5 days a week, 52 weeks a year, was rate valve springs. In that era,
Yikes.
every single part that came in the engine, that came in that shop was checked. Every single part. Every piston ring, even though we light type checked it at Total Seal, was light type checked at Joe Gibbs Racing before anything went in the engine. Every rod, every bearing, everything was weighed and checked. Nothing was left to chance. Okay, that was a really unique era. That was something where, to build engines, for 3 cars back then, the operating budget was $15 million to build engines for 3 cars for 36 races per car. Do the math, it's a little over 100. It's 108 races a year. So you built 108 engines at $15 million. Do the math and figure out what that is per engine. Okay, that's not real world. That's not what anybody else does. But we all see that on TV and say, well, oh my God, those guys hardly ever blow up an engine. That if you blow up an engine, well, then you're an idiot because you did something wrong. Hey, the reality is none of us had the time and the money to do the QC work that those guys do. And nothing's perfect. I mean, I don't care who you are. If you're making a part, if you're blending oil, if you're blending fuel, there's a spec, there's a target value, and there's a plus or minus. That's real life. Everybody has that. And sometimes the stack of tolerances work against you. Sometimes stack of tolerances work for you. Unless you're in that very unique, very fortunate situation where you can actually measure everything every time and know all of that, you live with some bit of chance. So I would never say someone's an idiot, that they did something wrong. It's that, it's just stuff happens. And sometimes we know from experience that some things you have to pay closer attention to than others. I don't know if any of you guys were at ATC a couple of years ago, and they had a panel up there of different engine guys. They had Sonny Leonard and John Causey and Ed Pink and Keith Dorton. And John Causey said, we don't even check balance anymore. We get pistons and rods and stuff in. We just put it in. We don't even check it anymore. John Causey says in a mountain motor, they don't even check the balance.
That's interesting. Causey will lay it on the line for you. Go ahead, Mark.
I've got one more question.
And that's Causey. Yeah, go ahead.
Yeah.
Well, I've got one more question for Lake before we go. Because we've been talking about racing, and of course you've been super busy with moving jobs and getting set up with Total Seal and everything. But because it's the thing right now, have you seen the movie Ford versus Ferrari?
Yes, thank you for asking. I took my wife and my kids, and we went and saw it. My boys, we went and saw it Saturday night. Well, I'm going to say this. If anybody has watched that movie or even thinking about watching the movie, I highly, highly, highly recommend, if you have Amazon Prime, it's called The 24-Hour War. It's a documentary.
Saw it.
That's
it's
essentially
awesome.
The real documentary. Yep. Oh, my God. Adam Carolla, he's a car guy. He's a comedian. He's
produced
a car
good
guy.
Stuff.
He basically produced it. Oh, it's fantastic. And then the 24-hour, the Ford versus Ferrari was great. Even my wife liked it. And she doesn't care about cars, right? And I thought it was a fantastic movie. I loved every bit of it.
Perfect.
That's awesome. The 24-Hour War was really good. I watched that the other day on Netflix, and I have not seen the Ford versus Ferrari movie yet, but I am going to before this weekend. I promise.
And 24-Hour War is also available on Blu-ray because I was able to order it, and I have it in my possession on Blu-ray.
Nice. Okay, cool.
Oh, yeah. Alex E. Lond E. Ken Miles. Christian Bale just channeled Ken Miles. I'm not sure how accurate that really was. But the other day, I've known Adam Carolla for a while and been fortunate to be on a show a couple of times, and he did an interview with Christian Bale, and Christian said he spent a lot of time with Ken Miles' son Peter, and really made sure that he was really portraying his father correctly. And in fact, he said, that Peter, when they did the screening, just hugged Christian and cried and said, you did it.
That's cool.
That is a fair representation of my father, and
Bale
when I heard that,
notoriously hard to work with.
I almost cried, right?
Yeah.
Well, yeah, but it was awesome. I think that was great.
That's
so
good.
Yeah, it's good stuff. Yeah,
and just so you know, Alex Londy is a friend of ours that works at a place that restores Grand Prix cars. All the way from like really old stuff from the 60s all the way up to relatively modern Formula cars from like the last 5 or 6 years. There's a place in St. Louis that he works at that restores these cars and takes them and runs them out. So yeah,
what
Alex,
are you saying?
dude.
Really old stuff from the 60s. Really old stuff.
Old stuff for people from our generation.
Like,
boomer.
Old stuff is pre-war. Yeah. Old stuff is pre-World War II. That's old stuff, man.
Yeah.
Listen to him.
Bill,
okay, got it.
Caller, around here we call that vintage.
Okay.
Yeah. All right, I got to play some music here and let you guys out. But I'm going to let you guys go. I'll mute these guys, but huge thanks to Lake Speed Jr. tonight. It's good to see you improving and doing things in your career. We'll try to look you up at PRI and see if we can't chat with you and kind of catch up, maybe do a little interview there. But anyway, thanks everybody for tuning in tonight. It's 10 o'clock Central Time. Time to go. We'll be in touch. Talk about next week. I think we'll still go ahead and do a show Wednesday, even though most of us will be en route to PRI. So everybody take care, be safe, and keep them engines tuned up. We'll talk to you shortly.